All right. Everybody hear me okay? Sounds good. I think we're right at starting time, so we'll go ahead and get started just so we can get you as much useful content as possible today. How's the conference going for everyone so far? Anyone feeling like you're a sponge that's fully absorbed everything you can yet? That happens at the end of the first day sometimes. Well, thanks for coming anyway to learn something new. We're going to talk about upgrading legacy ASP.NET applications today. I want to start out by just talking a little bit about why. It's been 8 or 9 years now that .NET, modern .NET, or .NET Core has been around. And it might make some people think like that's it for legacy migrations, like we've done it all by now. But as you might know, .NET Framework was around for a little bit longer than that, even before that. And when you add that all up, there's a lot of legacy code that still exists out there, and some of you might be the proud owners of some of that legacy code. Maybe that's why you're here today. But you also know, if you've been attending any of the great talks at this conference about .NET and .NET Core and ASP.NET Core and all the great new things that come from modern .NET, you know that it's a much more performant framework than .NET Framework. ASP.NET Core has been rewritten from the ground up, as all of .NET really has been in this modern era. And everything is easier to write and more modern and deployable in different scenarios and different operating systems and Docker containers. And there's so many pluses to getting onto this modern stuff. A lot of times, the only thing stopping you from upgrading to that Lamborghini is the ability to bring this legacy code forward with you. So tons of advantages to doing it. The only bad thing is that if you're doing an ASP.NET to ASP.NET Core migration, is that it is not quite as easy and automatic as some of the other ones, because there's a lot of breaking changes in ASP.NET Core. So today what we're going to talk about, first of all, is some of the different approaches, and the one that I'm going to talk about today and focus on that you might use when gradually migrating something over a longer period of time, like an ASP.NET application. We're going to talk about how reverse proxies, something called reverse proxies, play a role in that, something you may or may not already be familiar with. We'll talk about a reverse proxy called YARP specifically, and how you can use that. Also talk a little bit about the .NET Upgrade Assistant and how we can leverage that to make these migrations easier. And then we will do a live YARP migration. So you'll actually see me do one live here on stage today. And then finally, I want to talk a little bit about something called the System.Web adapters, which is something that helps you bring forward, it's a shim library that helps you bring forward a lot of code that you might have that uses the System.Web namespace. So before we get into that, just a quick introduction of myself. My name is Jonathan Tower, J for short, so if we get a chance to meet after the conference, feel free to do that, to call me that. I work at a company that I helped found called Trailhead Technology Partners. We do custom software consulting. We help our clients build custom software applications. I'm a Microsoft MVP in .NET, have been now 10 years running. Also, I've got a bunch of places you can contact me here on this slide if you want to contact me online. And then also just want to mention that I have a podcast called Blue Blazes that is all about helping make software projects more predictably successful. So if that sounds like something like what we're talking about today, you'd like to listen to more of that or watch more of that on video, you can check out that podcast. Last couple of things I'll mention on this slide before we jump into the content. If any of the code or slides today is something you want to reference again later and you don't get a chance to get your phone out and take a picture, you can go to this GitHub link right here, and you'll be able to download any of that stuff you want. The last one is that anybody that comes to one of my talks, I like to offer them the ability to connect with me for a consultation. So if there's something we talk about today that feels applicable to something you're working on, you want to talk about .NET in general, consulting, any of those things. I've even had people contact me about basically, hey, I attended your talk and it was very helpful and I wish my team could see it. Could you actually do it again for my team? All of those things are possible if you want to use that bit.ly link or that QR code that's on this slide. You can put a time right on my calendar and we can meet to talk about that. All right, so jumping into it, the first thing I want to do is I want to make sure everybody is on the same page about this terminology. My assumption is everybody knows this that's been doing .NET for a while, and yet when I do this slide, there's a lot of like aha moments that seem to happen for people, and so maybe this is something that will still be useful for you. So first of all, .NET Framework. When we talk about .NET Framework, we're talking about the legacy .NET. This is the .NET that is on Windows only. In fact, it is technically part of Windows, and that means that you can't run these things easily. You can use some things like Mono to try to run them elsewhere, but generally speaking, you run this stuff on Windows. This went from version 1.0 that started around 2001 up to version 4.8. I think 4.8.1 is the current latest version. And right about the time .NET 5 came out, that was basically, it was announced that .NET Framework was going to be maintained, supported, but no new development. So nothing new. There's not going to be a 4.9 or anything like that in .NET Framework. But back in about 2015 or so, Microsoft started working on something they called .NET. They actually called it a lot of different things. They eventually called it .NET Core, and they went live with version 1.0. And you might have been following it since then. Versions 2, 2.1, 2.2, and so on all came out until you got to 3.1. And at that point, it became clear that due to a bunch of technologies that Microsoft had created, like something called .NET Standard, that we'll talk a little bit more about today, that they could basically merge all of these .NETs back into one thing and just call it .NET again. And so this new thread of .NET that has been rewritten to be cross-platform, modern, and performant is now just called .NET. So from version 5 to now we're on version 9. All of those versions are just referred to as .NET. So this gets a little confusing, especially when I'm doing a talk about legacy migrations, and I have to keep saying .NET Framework, .NET Core, .NET. And so you might hear me call these a few different things in the talk today. When I say modern .NET, I'm talking about .NET Core and .NET. And when you hear me say legacy or .NET Framework, I'm talking about the old one. So that's kind of what we're going to be looking at today. Further confusing things is the branding of ASP.NET. So ASP.NET had an original version that was only for .NET Framework, and that was just called ASP.NET. Anybody old enough to remember where the ASP part of that came from? All right, some other gray hairs in the room. So active server pages was a scripting language, VBScript, that existed before .NET that you could do web programming with, and this was basically Microsoft's attempt to bring those developers forward into the .NET web programming world. They said, don't worry, it's just what you're familiar with, except it's on .NET now. So ASP.NET and .NET Framework, but then when .NET Core came out, ASP.NET had a new version that was for .NET Core called ASP.NET Core. All makes sense so far. Confusingly, though, ASP.NET Core originally could run on both .NET Framework and on .NET Core. Why? Again, for that transition crowd, right? The people who are like, hey, I'm not allowed to deploy anything new to my servers yet, but I want to run ASP.NET Core. No problem, you can run it on top of .NET Framework. That was true until version 2.2, and then Microsoft cut that off. And now the world that we're in basically is that all ASP.NET Core versions, modern versions of it, run just on .NET or modern .NET. So hopefully that clears up some things in your head so that as we're talking about the rest of this today, migrating .NET Framework to .NET, you're resonating with what I'm talking about. So there's a couple different approaches that I want to talk about. There's probably hundreds of different ways you could approach these projects. These are the two probably most popular ways I see a migration project attempted. The first one is the Big Bang attempt. This is, you've been part of one of these. If you've ever been locked into a conference room with your colleagues and told not to come out until the application is migrated. This is also called kidnapping, I think. But this doesn't work very well unless you're talking about a very small application, right? First of all, it's not very agile to say, let's do this whole big thing all at once. If you're talking about a complicated application, it's also very risky. The chances that you migrate everything, find all the problems are going to be very low when you do it all at once. So you might have seen or been involved in a project like this where it takes months or years to do a migration project, and then it goes live, and maybe it's a little bumpy for the first few months that's in people's hands. And of course, we can avoid that by using a different approach that's more agile, and that is the Strangler Fig approach. So I actually got to see some of these when I was in Australia last year. Anybody ever seen a Strangler Fig in real life? No? Okay, well, there's a picture of one for you. It works in a really interesting way. So what actually happens is the seeds will usually be picked up by birds and dropped. When they're dropped, sometimes they'll kind of land in the canopy of the trees. They'll then basically start growing a vine down the trees until they reach the ground, and they'll then go into the ground, start getting nutrients out of the ground, water, etc., start to wrap around the tree's roots. Eventually, that tree is not able to get what it needs to survive, and it becomes basically a dead tree, a dead backbone, and the Strangler Fig then kind of grows around it. And so you get sort of a slow motion, violent example here from nature. But this is actually a really good analogy for what we do when we do a gradual migration. So what does that look like with a web application? Well, imagine you have a legacy application. It's got the majority of the code in it. And you maybe create a new modern application that initially has very little in it, or maybe is empty, just a placeholder. If you put a facade layer that basically ties those two together and makes them look to the consumer, whether that's the end user through the UI, or whether it's an API layer being brought together so that the consumers of that API all see it as one coherent thing. Whatever that particular web application is, if you have that facade layer to do that, then what you can do is you can gradually migrate or even rewrite parts of that application, moving it over into the modern application. Now, the modern application eventually gets to have the majority of the functionality in it. And eventually, if you keep plugging away at it, you actually get to the point where the modern application is the only thing left. Now, theoretically, at least, you could get rid of that facade layer and you've completed your migration. The benefit of this approach is obviously that the entire time you're doing that migration, you can be doing little updates, much more agile, and the end user can actually be taking advantage of that. So if you move one endpoint of your API over to the modern application, you're able to rewrite it in a way that performs better, takes advantage of some of the features in modern.NET, and basically benefits your end users. They can start having that right away. As soon as you roll that out, that facade layer will bring the two applications together, make them feel or seem like one, and then eventually you end up migrating things. Much more agile. So let's talk a little bit about a reverse proxy and what its role would be in this type of a migration project. A lot of us might be familiar with a forward proxy, or what probably people just usually refer to as a proxy server. I am old enough that when I started in the industry, I remember some companies where I worked or I consulted that they didn't have internet access on every computer on the computer network in the office. There would be one computer that would have internet access, and if you wanted to take advantage of that and access the internet, you would actually have to set a setting in your computer that would say the proxy server for my computer is this IP address on this network. Anybody else? Does this sound familiar to anybody? Okay. Same hands as before when I asked what ASP stood for. So that's a proxy server. That's a server that is acting on your behalf or proxying on your behalf out to the internet. That's also called a forward proxy. So that's what you see in this example. Computers on a network using a particular server to access the internet, and then the various internet servers out there on the internet. That's a forward proxy. If you basically just swap the order of the middle two pieces of this, you end up with a reverse proxy. So now imagine clients out on the internet, browsers, let's say, coming in through the internet, and instead of hitting your web server directly or your firewall and then your web server, the first thing they hit when they come into your network is actually a reverse proxy. That reverse proxy then can look at that traffic and say, where is this actually headed, and make a decision based off of the path or something in the headers or something in a cookie, any of those types of things that the reverse proxy could do, and then decide which server to actually route that traffic to on the back end. So that's all a reverse proxy is. They can be used for all kinds of very cool and useful things. For example, you can do A/B testing with them. So if you have an application where you want to roll out a new version, maybe you've got load balanced servers, You want to roll out a new version that works a little bit differently. You've probably seen this if you've used Microsoft or Google things. They'll sometimes have do you want to use the new interface? And you can say yes, and then if it stops working for you, there'll be a little button you can click to go back to the old interface. So kind of A/B testing like that. URL rewriting. If you've got very complicated back-end API URLs and you want to simplify them, or maybe bring a bunch of different applications all together under one application path, you can do URL rewriting with that. Often like security or microservices security layer is done with this type of technology, like a reverse proxy. Feature flags is another thing I've seen it used for. And then finally, the one that I want to talk about with you more today is the incremental upgrades. All right, so we talked a little bit about the Strangler Fig as an approach. We talked about what a reverse proxy does. You might be seeing how this comes together already in your head. But let's talk specifically about YARP and what that does. So YARP is Microsoft's reverse proxy. It stands for Yet Another Reverse Proxy, which is a great name. And basically, it came out of the fact that a bunch of teams inside Microsoft, product teams, were doing their own web applications, and they were kind of doing their own solution for reverse proxies. So some people were using third-party ones. Some people had kind of created their own based on their needs. And eventually, one of these teams got wise enough to ask the .NET team, hey, do we have a solution for this already inside of Microsoft that is like the solution that we're telling other people to use? And the answer was no. And so that was actually then created for that particular product team. And then eventually, this became something that more teams inside of Microsoft were using to do their own reverse proxying. And because a bunch of reverse proxies already existed, the name Yet Another Reverse Proxy. So how does it work? Well, it's a NuGet package that you install into a ASP.NET Core application. And then when traffic comes in from clients, it hits that ASP.NET Core application first. Now, you might know ASP.NET Core well enough to know that it's got this thing called middleware. There's a request response stack, essentially, that is created by this middleware stuff. So if you're doing minimal APIs or MVC or any of the different frameworks that exist in ASP.NET Core, all of those are basically just middleware that plugs into that request response pipeline. And you can do the same thing with YARP. When you install YARP into your application, you'll just add it to the pipeline. And you can see here it's actually in the pipeline above MVC, which is also where APIs would go as well to MVC. So now when that request comes in, it'll start at the top of the pipeline. And if YARP gets that, it'll look at it and say, does the routing table already have this URL registered in it? Now, if you're not familiar with the routing table, this is something that's existed in ASP.NET since the beginning. This is basically whatever frameworks exist in ASP.NET or ASP.NET Core, they're able to basically register all the routes that they're able to handle. And then what happens if you hit any other URL in that application, you get a 404 error from ASP.NET, right? So YARP is going to look in that routing table and say, do I have anything registered in this particular application to handle this route? And if it says, yes, I do, then it's going to go ahead and just forward that down the pipeline for whichever application framework down the pipeline actually registered that route. It will go ahead and be able to handle it. What happens then, obviously, is if you have a controller class or a minimal API or whatever the particular code is for that endpoint, it's going to forward it to that code, and you're going to get the response back out from that code. What happens if the opposite happens? If you get a request into YARP, and it looks in the routing table and does not find that URL, this is normally in ASP.NET when you would get a 404, or at least it would pass it down the pipeline for someone else to decide if they were able to handle it. In this case, what it does instead is it forwards the request or proxies the request through to the legacy application. So now it says, I don't know how to handle this. Instead of returning a 404, I'm going to just skip the whole rest of the pipeline, and I'm going to pop this out to the legacy application I was configured to use. And then that application is going to do whatever it does internally to handle that request, whether it's a static file or an endpoint that hits a controller class or whatever it is, it's going to be handled there and be returned back to the user through the proxy. So what does that look like? Well, if you look at my example from before, where we've got the facade layer with the modern and legacy apps behind them, this is what it looks like in concept. This is what it looks like in reality for someone using YARP. So YARP, I told you, actually is hosted inside the modern application. And so even though there are conceptually three pieces here, there's the modern, the legacy apps, and the facade layer. Here, the YARP facade layer and, let's say, the Blazor modern app are actually going to be hosted inside the same application, your modern ASP.NET app, and then only stuff that isn't able to be handled from that will be forwarded to your legacy ASP.NET application. So there's a ton of, as you would sort of guess from the name YARP, yet another reverse proxy, there's a ton of reverse proxies out there. So why bother creating another one, right? Why not just use these? And the answer is you can use these other ones, and they will be able to functionally do all the things that you want them to do. So what are the advantages of YARP? There's a bunch of them. First of all, it's very easy to, first of all is performance. So from the ground up, Microsoft wrote this very well. Just like a lot of other things in modern.NET, it's written for performance as a first-class citizen. Or in other words, performance is a feature. So it works really quickly. Not to say the other ones don't, but this one does as well, so that's at least not a negative against it. It's super easy to use if you're a .NET developer. Using YARP is as easy as bringing in a NuGet package into your application. You might want to add a couple of lines of code or some configuration, but for the most part, bringing in the NuGet package and you're 90% of the way there. Very easy to use. Also, because if you're a .NET developer, you're going to find it very easy to extend it, to configure it, to make it do exactly what you need it to do. You can also customize it. It's extensible with C# and your .NET skills that you already have. And then the last one is kind of a funny one, but that diagram that I just showed you, where there was only two pieces, two physical pieces of application, even though there are three conceptual pieces, because the modern application actually hosts the YARP part of the facade layer, you actually have two things to deploy. Any of those other reverse proxies you use, you're going to have to deploy updates to your legacy app, to your modern app, and you're going to have to deploy, let's say, configurations and updates to your facade layer or your reverse proxy as well. Now you have that all hosted in two things. So it's a 50% reduction in things you have to deploy, basically. So a lot of use cases that I've seen for this already. We're using this at Trailhead all the time for our clients. We've even used it a little for our own internal products that we use to run the business. I've seen a lot of things where there was a legacy application and they wanted to go to something modern.NET. And you'll notice even PHP in that list. And you might be thinking like, oh my goodness, can I go from classic ASP to PHP? And the answer is you can go from anything that does HTTP to any modern .NET web technology. So no, you can't go to PHP if you want to use YARP, because you need to host that inside of a modern .NET application. But any modern .NET web technology, ASP.NET Core, MVC, Web API, minimal APIs, Blazor, Razor Pages, all of this stuff is totally possible as a destination for your code. And then you can be coming from basically anything that speaks HTTP, whether that be a Microsoft technology or a non-Microsoft technology. Now, the most common story that you'll hear is some older thing like web forms running on ASP.NET or MVC running on ASP.NET, something like that, Web API. Those are the most common scenarios. I'll tell you a couple of very specific examples here. So one of them is coming from classic ASP and going to a Blazor client front-end application with an ASP.NET Core Web API backend. This is something that we helped a client do. And as you can see, a lot of different technologies involved. And maybe the most noticeable change here is that the application was essentially a client-server, simple server-side rendering type application before. And now there's an API layer. And so you might be thinking, how did you do that? Well, basically, in this case, when somebody routes to part of the application that has been migrated, that page gets routed to the Blazor application, and that loads up the UI, and that then starts making API calls. Versus if they hit part of the legacy application, they actually will have to do a full round trip for the entire page every time they hit a page or make a change. Another option would be to do the same thing, but to do it with a Blazor server-side rendering. And so this would be using more like SignalR to communicate back and forth between the front end and back end. Maybe you've seen this before, or maybe you've seen this in some of the talks at the conference so far. And then another common application architecture that we help people move to from a classic ASP.NET application is moving to a front-end, back-end technology like this with a SPA framework like React, Vue, Angular on the front end, and then an ASP.NET Core web API on the back end. So a lot of different options that we've seen and made work. I want to give you a specific example if you want to look at it afterwards. I won't go through this with you today, but I wrote a blog about this, and it's kind of a very simplified example that I made so that you could see what it would look like if you were moving from a web forms ASPX type application to a Blazor application. In this case, it's a Blazor client application. So if you want to check out that blog, you can go to that bit.ly link there. Obviously, this will be on the GitHub as well if you want to check that out afterwards. The last thing I want to talk about a little before we get into a particular example is the .NET Upgrade Assistant. This is something that I'm going to show you in just a minute, but it's a really powerful extension for Visual Studio as well as a tool that you can add to the .NET CLI. And this helps you upgrade all of your .NET applications to newer versions of .NET. So it can do anything from what we're talking about, which is like a .NET framework, legacy application, all the way to modern .NET, or it can even do like a .NET Core version of .NET to .NET, or even just .NET 5 to .NET 9, or .NET 6 to .NET 8, or any of those kind of modern to modern .NET upgrades it can help you with as well. Obviously, the higher up this list that you go, the more helpful it is to have this tool, because the further down you go, say you're upgrading from .NET 8 to .NET 9, you're going to find that that's pretty easy to do even without any help. So the harder the lift is, the more this tool will be helpful. We're going to look specifically at using it to upgrade ASP.NET to ASP.NET Core, but it does a bunch of other things as well that we aren't going to look at together today. So if you're doing a WinForms application that you're upgrading, or WPF, or Maui from Xamarin Forms, or even a console app, all of these things, including class libraries, are all available as a potential that this .NET Upgrade Assistant can help you do an upgrade on. So with that said, I want to actually get into the demo, and we can look at this together. All right, so let's see if I can share my screen successfully here. Perfect. Okay, so I have an application here, and it's got two pieces in there. I know it's a little small, so I'll just read it out to you. It's a utilities class library, as well as a legacy MVC application. If we actually look at the code in the legacy, let's go ahead and make that a little bigger. Okay, hopefully that's a little bigger for you. So basically, this class library does something very simple, which is it accesses the HTTP context object, and then it just reads a particular header out of the request. In this case, the user agent header is read for you. Obviously, this is very simple code that you probably wouldn't have something exactly like this. But what I wanted to show you is that System.Web is something that basically doesn't exist anymore. So if you move from ASP.NET to ASP.NET Core, System.Web is basically that entire namespace is all the stuff that was wrong with classic ASP.NET. So that has gone away. That has had all the hard-coded ties between ASP.NET code and IIS, and all of that stuff had to be rewritten. I know from some insider information that Microsoft has looked a few times in the past at whether this would be possible to rewrite, to bring things like web forms forward into ASP.NET Core, and the answer is no, it is not possible. It's too big of a lift, basically because it's so hard-coded. So anyway, this is accessing the HTTP context, which, if you don't know, is defined in the System.Web namespace. So basically, this is going to be a problem to upgrade, right? Because this doesn't exist in ASP.NET Core or .NET Core. Okay, so that's the first thing I wanted to show you. I want to also show you the version that this is set to right now. So if I go to the properties for this project, you can see it's set to run on Framework 4.8. And if I go to the web project and go to its properties, you can see similarly that this is set to run on Framework 4.8 as well. Okay, so these are both Framework 4.8 full framework applications. And the last thing I want to show you is under the controllers here, you can see I created a simple controller that's actually using that library that we just looked at. And it's calling this get header method that we just looked at, passing in the current HTTP context to it, and getting back a string which is being set basically into the view. So if we look at the view for this, you can see System.Web view is basically displaying the user agent on the screen inside of our default layout. Okay, so real simple application here. It's just doing a few things to show you what are some of the problems that you'll run into in this process. So I'm going to go ahead and run this. Oh, well, isn't that lovely? So we just got to get rid of this right there. So while this is loading up, I want you to notice that the port number that we're hitting here is 50,295. Now, you don't have to memorize that. Just remember it's this 5-digit number that starts with 50. That's going to be important to notice in just a minute here when we start doing this migration process. Because as you might imagine, during the development process, I can't have two totally separate web servers running on port 80 or 40 or port 443. And so as a result, what's going to happen is these two web applications are going to run on two separate ports. So this 50,295 is the one that is my legacy application. Now, just to prove this is a real application, I can come in here to edit, and I can make changes. I can create a new one. So basically, all this functionality works. And if you've been doing .NET for a long time, you might recognize this pretty ugly example as a very old MVC eShop example that I just literally stole from a Microsoft GitHub account. So very simple, classic ASP.NET application. All right. The last thing I want to show you in the application is if we go to that System.Web URL, we're going to get the entire layout of the application with the header and footer and all of that. But we're also going to get that content that we saw, which is the user agent being written out onto the screen. So it's basically saying that I'm accessing this in that particular version of Edge. Okay? So that's the legacy application. Let's look at what it would take to actually upgrade this. So the first thing I want to call your attention to is under the extensions here. There is an installed extension called the .NET Upgrade Assistant. This is what I was talking about a minute ago. If you don't have this already, you're going to want to go install this to be able to do what you're about to see. If you're a .NET CLI user and you want to do all of this, it's all doable from the .NET CLI by just installing the tool that's also called the Upgrade Assistant. So what we're going to look at is going to be through the GUI in Visual Studio. All of it is equally doable from the command line. You will notice one little important detail about the .NET Upgrade Assistant. It is in preview. I will say it works quite well for something that's been in preview now pushing 2 years. They are actively working on it, but you will see one example of a thing that it doesn't do perfectly in my demo here. And I think they're basically waiting until it's a little bit more like 99.99% of the way there before they say it's not a preview anymore. So you can use this for real production use to upgrade a real application. Just keep in mind that it's not perfect. Okay, so first step first here, we've got a class library that I need to upgrade. This class library is obviously referenced by the web application. If I try and update the web application from framework to core, and I don't update the class library, the very first thing I'm going to run into is that it can't reference the class library, and it's going to be broken until I fix that. So let's skip that problem by just upgrading the class library first, which is probably what you would do in your upgrade project anyway. So I'm going to come here, and you'll see there's an upgrade option now in my right-click menu. I click on that class library project and pick upgrade. It's going to give me a number of different options. I'm going to do the thing that you probably wouldn't do in real life, which is to do an in-place upgrade. This basically means it's going to do it in the same folder as the project currently lives in. Obviously, this is a little bit harder to roll back, not if you're using source control or something, but a little bit messier if it doesn't go well. But I'm going to do that anyway. Now you can see I get a bunch of different versions of .NET here, as well as a couple called .NET Standard down at the bottom. If you're not familiar with .NET Standard, I used to do a talk about it that was a whole hour. Just what is it, how does it work, why is it useful? We don't obviously have time to go into that today. But I do want to mention what it is, just so that you understand why I'm going to select one of those things. .NET Standard, you can think of it as it's a standard that .NET classes can compile against, class libraries can compile against. It is not another full implementation of .NET. So you might have heard of like Mono and .NET Framework, .NET Core, .NET Micro even exists out there. All of these things over the years have been created that are different flavors of .NET that run in different environments. This is not one of those, but it is a solution to the fact that there are so many flavors of .NET. If you want to create a class library and use it on .NET Framework and .NET Core, how can you do that? Well, you have to compile it against some third thing that isn't either of those two things, right? And the third thing that you compile it against is .NET Standard. And there's different versions of .NET Standard. We're used to thinking of versions as being the higher the number, the better, because that's how most things go in the software world with versions. In the .NET Standard world, as you go up in version numbers, you have more APIs that are included in the standard, but you have fewer deployment platforms that you can hit. So if you want to be able to go the furthest back to the furthest old things, .NET 4.6 is where it starts, for example, you're going to want to use a smaller .NET Standard number, a lower version number. Now, I've only got 2 and 2.1 here right now. 2.0 is going to be the one that goes back to .NET Framework 4.8 for support. And if I do 2.1, that will not support any version of .NET Framework. And so I'm going to go to .NET Standard 2.0. And this is going to allow my class library to compile in a way that can be run by both .NET Core and .NET Framework. So I'll pick that and just say next. It's going to give me the option to check or uncheck things that I do or don't want to migrate. There's only basically one class in this library anyway, so I'll just go upgrade it. And it's going to give me kind of a progress upgrade notification, as well as this warning that says basically you're using System.Web, and that's going to cause you some problems, right? So we already talked about that, so I don't need to do anything special with that. Now, if I go look at the project properties, let's try that again. If I go look at the project properties here for the class library, instead of saying 4.8, you'll notice that it is now compiling against .NET Standard 2.0. Okay? So we have basically successfully upgraded our first piece of our application. And it was as easy as right-clicking on it and clicking a few things. Now, we also know that there's going to be some more problems. What would a good upgrade talk be without some more problems that we're going to run into? But we'll go ahead and face those as we come to them. So let's move on to the next step, which is upgrading the web application. So I'm going to click on that and pick Upgrade. Now you'll notice I get a different set of options here. And the one I want to call your attention to is the side-by-side incremental upgrade. And if you read that whole description underneath it, you'll see it mentions YARP, and it talks about a few other details about how that implementation is going to be done. But you'll notice there is no in-place migration like we saw before. Why is that? Something I referenced very early in this talk is that when you're doing ASP migration, ASP.NET to ASP.NET Core migration, that it's a much more complex upgrade. If you have a large legacy application, there's a very low probability that you're going to do this upgrade in a day or an hour or anything like that. It's probably going to take you months, weeks, something more along those lines. And so as a result, it makes a lot more sense to do it side by side and use YARP to help bring the two together, like we've been talking about so far with the Strangler Fig pattern. So I'm going to pick that. Now it gives me the option to basically pick an existing ASP.NET Core project, which I don't have in my project yet, or to do a new one. So new is the only option I have. I'm going to change how it names this to be Core MVC. So we have the legacy MVC and Core MVC will be our two web applications. And now you'll notice I get a different set of upgrade options. I get 4 different versions of .NET that are installed on this computer, .NET 6, 7, 8, and 9. No .NET Standard. Any guesses as to why there's no .NET Standard option in this one? Yeah? That's right. There's no underlying implementation for .NET Standard. It's only something you can compile a class library against. At runtime, you have to run against an actual implementation. So .NET Standard is not one of those. .NET Core or .NET is. .NET Framework is. But .NET Standard is not. So this is an actual web application that has to run. It has to run at runtime. It can't be referenced by something else to run, like a DLL or a class library could be. And so it actually needs to have a real .NET implementation. So that's why we get those choices. So I'm going to pick .NET 8, maybe because let's say I'm a more conservative organization, and I want to do the long-term support version of .NET, not the most recent one that is going to be only supported for a year and a half. So I go ahead and pick .NET 8. OK, so now it's going to give me kind of a summary of the things it's going to do. And I'll go ahead and click Finish to get that started. So you can see, like before, I'm getting the step-by-step what it's doing, getting kind of a progress bar as it goes through that. And in just a second here, it'll finish up, and you can see all green checkboxes. So everything was successful. Now, if we go look at what is in that Core MVC application, you can see there's a program CS, and there's a properties folder, and an app settings JSON. It's basically a new empty ASP.NET Core application, right? For all intents and purposes, this is a new empty application. So if you think back to my earlier diagram where the legacy application was big and the modern application was small, that's the state that we're in right now. But if we look at the program CS, there's a couple things I want you to notice in here. Right here, it's adding something called HTTP forwarder. And if we look at where that comes from, you can see it's coming from a NuGet package called YARP.Reverse Proxy. And right here, you can see app.map forwarder. And this is doing what is called a catch-all route. You can think of this as sort of like a wildcard. So this is basically saying if something comes in and it's kind of /anything, then go ahead and route it to the legacy application if it doesn't exist in the routing table for the modern app. Where to route it to is this right here, this parameter. And you can see that's actually being pulled out of configuration, out of the proxy2 setting. So if I go here to my properties, launch settings, we can find that proxy2 setting right here. And you can see it's proxying to localhost 50295. 50295, anybody remember that number from before? That's the port for my legacy application, right? Now you'll actually notice that this application is being set to run on these 4-digit ports. So we'll probably see it here running on 5062 and the legacy application on 50295. So that's kind of how this is set up. The other thing that it does that I think is kind of cool is if we go to the startup projects. Before I only had one project that I could configure as a startup project, but now I have three projects, but 2 of them could be startups. And you'll notice that both the MVC legacy and the MVC core projects are set to start. Why is that? Well, because if I want to actually test this application, I need the legacy and the modern app both running so that they can communicate with each other. Obviously, the utilities class library is not being start by default when I debug. And then the other thing I want to show you is the class library. I want to show you is the legacy MVC application here. If I go to the properties and go to the web tab, you'll notice, normally it does this right here for me. So it'll change it to don't open a page. So for the legacy application, I don't really want the debugger to launch it and open up a particular URL because I don't really want to see the legacy application. I want to see the modern application. Now, it will forward to the legacy application for me, but I don't need to do that, see that directly and have like two different windows, browser windows open. Okay. So with all of that, let's go ahead and run this and just see what it looks like. We saw the application before, so let's see what it looks like now. So we'll go ahead and run this. And when it pops up Edge for me, you can see it's hitting the 7060 port that we talked about before. So this is my modern application that it's actually hitting. Now it's taking a couple seconds longer. Why is that? Well, because now the resources of my laptop are launching two ASP.NET and an ASP.NET Core application all at once. Waiting until the ASP.NET one comes up, then the ASP.NET Core one is coming up because of the way I ordered them in the startup. And then my request can actually be handled. The core application receives it, finds that it is not handled yet in the .NET Core application, and so it forwards it through the reverse proxy to the legacy application. Now you might be saying, like, it looks like we haven't done anything yet, and that is technically true, because now we basically have a modern application that just forwards 100% of everything through to the legacy application. But if your boss asks, you can say you're done now, right? You have now migrated it to a modern application. No, not yet. So what does it look like now? This is a really cool feature. If I go back to this legacy MVC and go back to the upgrade option, I hadn't clicked done yet. Let me click done and then do it one more time. So the next time I come back to this and pick upgrade, it's going to actually show me a new interface than what it showed me before. So if you tell your boss that you're now done, don't let them see this, because this is going to say that you're 0% done. Because you can see, of all the endpoints that it found in this application, 100% of them right now are on .NET Framework, and 0% of them are on .NET Core. So this is kind of a cool little dashboard where you can actually come to see how are we doing, how many of these endpoints that exist in this ASP.NET application have been migrated over to the ASP.NET Core application. You can also come here as a way to kind of start the migration process. So let's actually migrate something by going here to this update controller, and then we'll pick that System.Web controller that we saw earlier. And I'm going to say I want to upgrade that now. So I'm going to upgrade that. It's going to say I have to do some classes, I have to do some routes, and I have to do some views. So you can kind of look at all of that stuff. You can check or uncheck things if you do or don't want them included. I'm going to do everything. Now, included in that, if you think about what was actually happening in that application, that System.Web controller was essentially one line of code, right? But it referenced a view that was also one line of code, but referenced a layout page that was much more lines of code. And so that's quite a bit of things that it had to go figure out to migrate over. So let's see if it did. So first of all, under controllers, we can see we've got the System.Web controller. Here's that bug I was telling you about. It doesn't do things perfectly all the time. It saw a user agent, and it thought, I know what user agent is. And so it went ahead and changed that to be an API call like that. I'm going to change this to what it should have been, which is just a viewbag.userAgent equals that. Now it's still not compiling because we're missing a reference, right? We're missing a reference to that class from our new modern application. So I'm going to go in here to my modern application, and I'm going to go to dependencies, and I'm going to add a project reference, and I'm going to reference my utilities class, which is now a .NET Standard 2.0 project class library, so I should be able to reference it from .NET Core, .NET, or .NET Framework. And as soon as I do that, all my errors on this should clear, okay? But let's keep looking at what we were looking at, which is what else did it pull over? Well, under views, you can see there's a System.Web index view here, which is the same view that I had before in my legacy code. But there's also the shared layout. Now, I'm going to gloss over a couple of things that are commented out here because we're going to come back to it in just a second. But you'll notice that it's basically pulled over the entire, all of the pieces that it needs to, including the layout page, to make this work. So let's go ahead and run it and see if we can do that. Okay, so again, it's launching just one browser tab, but behind the scenes, it's launching both my legacy and modern applications. And I'm going to go ahead and just navigate to System.Web. Okay, so that kind of worked, right? I can now see a functional page, but not a particularly pretty page. It doesn't have the header and footer. It's obviously missing CSS that we need for this application. Now, if you're an eagle-eyed attendee, you might have already spotted why. Right here, something commented out. And then if I go down here, something related to that also commented out. So we're missing all of our Bootstrap, jQuery, CSS, et cetera. All of those bundles are missing. Now, why are those bundles missing? Because one of the inconsistencies between ASP.NET and ASP.NET Core is that ASP.NET Core has no bundling library like ASP.NET does. Why? Because there are a ton of ways to bundle things now. A lot of people use Webpack. There's other things that you can use to bundle things for web development. And Microsoft said, why bother reinventing the wheel? People are not using this bundling library anymore. We're just not going to bring it forward. So they didn't. Now, there was enough of a backlash with people who said, but I want to have server-side bundling in my C# code, that somebody created a library, a third-party library, to do exactly this. It's called LigerShark. And I'm going to grab a reference to it right here and show you how you could actually bring that into your application. So I'm going to go to the new core application here, and I'm going to add a reference to it. And so I'll go to the Browse tab, and I'll search for that LigerShark weboptimizer.core, and I'm going to go ahead and install that into my core project. Okay. So now I've got a couple of lines of code here that I'm just going to copy in the interest of time. But before I do that, actually, I need to have the actual content, so the actual JavaScript, the actual CSS that I want to use. I need to have that in my new application to be able to use it from there. So I'm going to kind of do the lazy approach here, and I'm just going to go to the legacy application. And I know that that is all coming from either content or scripts. So I'm going to basically highlight the content folder and the scripts folder. And then I'm going to copy those and paste them into my new project like that. Okay, so now you can see I've got a mess of content stuff and a mess of script stuff in there that I've just basically copied in. The other thing that happened when I copied that in is it will have actually edited the project file for me, and I don't really love the way that it does this. It basically goes through and enumerates every single file. I want to actually say, instead of file by file like that, I just want to say, if it's in the content folder or the scripts folder, let's go ahead and deploy it with the application. So instead of that mess right there, I'm going to use this little bit nicer syntax that basically says it with wildcards. Okay, so now I'm saying, if it's under the content folder or if it's under the scripts folder, let's go ahead and deploy it if it's newer. Okay? Next step is to basically create those bundles with the LigerShark library. The way that looks is to basically add the use web optimizer code and then to actually configure the bundles. So I'm going to go do that in my startup program, CS. So right here, let's see, right here, I'm going to use app.useWebOptimizer. So that's where it's going to insert the LigerShark library into my request response pipeline. And then right here, I'm going to paste in this code that basically reconfigures the bundles that I had in my old code. This syntax is almost identical to what you did with the bundle configuration in your legacy ASP.NET applications. It's just slightly different, so you could kind of copy that over and then tweak it to basically work with LigerShark. All right, so now with all of that in mind, I should be able to run that application now and have that new page on my new modern application actually have CSS. Oh, except I forgot one step. Which is to actually comment in those script and style sheets. So I'm going to go back to the layout, and I'll just paste in these tags here that reference those in a more in a non-server-side way. They're just referencing them the typical client-side way that you would do it. All right, now I've done all the steps that I should do. And so now the new application actually has references to these bundles using the LigerShark library. It's actually building those bundles at runtime. And I should be able to go to that /System.Web namespace and have it get those bundles. So let's test it out. OK, there we go. So you might not be able to tell, but what's kind of interesting, if you think about what's actually happening here, when I come to this page, the original request for the page itself, the main host page here, is being routed by YARP to the modern application. It's not being proxied through. Then the requests for all those bundles are also now not being proxied through anymore because we just replaced them with LigerShark. However, when I go to this page does not exist in the modern application yet. And so what's happening here? First, the request for the slash page or the index page is going through YARP and being reverse proxied to the legacy application. Then that's coming back through the modern application as a response. We're getting the page, and then all of the other content it's asking for here, the images, the CSS bundles, the JavaScript bundles. Initially, those were coming from the legacy application. But now that I've created those bundle routes on the modern application, now this page is coming from the legacy app, but all of its CSS and so on are coming from the modern app. So you could say this page is sort of like half migrated at this point. All right. Let's get back to our presentation here. Just a couple other things I wanted to mention. So the System.Web adapters, once you get past the more trivial parts that I've showed you today, and you start to get into the weeds of doing a legacy migration, you're going to run into things like session state. You're going to run into things like authentication. These get a little bit harder when you're trying to make two applications use the same authentication or share session state with each other. There is a shim library that Microsoft has created that's called System.Web adapters. And it basically gives you two things. Number one, it gives you not all, but about 80% of the SDKs that exist inside the System.Web namespace as a modern mapping. So you can take code that was written against System.Web.http context, like the code that we saw earlier, and using things that are in that System.Web namespace. And if it's running in .NET Core, it'll map it to the modern equivalent for you, without you having to rewrite that line of code at all. If you're running in .NET Framework, it'll use the System.Web namespace for you. So it's a shim that kind of goes between you and the System.Web namespace and either gives you the old stuff or the new stuff, depending on where you're running. The second thing it does for you is it gives you the opportunity for your two applications to talk to each other a little bit with things like session state and authentication. So there's three different libraries, one that you would use for both sides, the System.Web adapters namespace. The core services one is the one that goes on ASP.NET Core applications only, and the framework services one is the one that goes on the framework side. You can configure these to talk to each other so that you can proxy through your authentication to your legacy application, and it can return with a cookie or whatever its response is, and then your modern application can actually get that information as well and be able to read that authentication cookie And now both applications are using the same authentication as each other. So a couple just FYIs about these tools that we looked at today. Two of the things that we looked at today are in release officially, so YARP and the System.Web adapters. You're good to go on those things. Just a heads up, it's pretty production ready, but the .NET Upgrade Assistant is still technically a preview release. So be aware that some of the things, like what we saw with the user agent line of code, might happen to you as well. That is it for my content. I am happy to take any questions. I think we've got like 1 minute left if anyone wants to come to the microphone and ask. Or I can repeat it. Yeah, go ahead.
Excuse me. Do you have any experience of migrating Windows Identity Foundation to a modern core framework?
Yeah, so the question is about ASP.NET Identity, I assume? Yeah. So if you want to do ASP.NET Identity, it is possible to do. The devil is in the details a little bit, what versions you're using and so on, but it is possible to do. And if you want to talk more about the details, I'd be happy to talk to you up here afterwards. Yeah, one more up here.
Okay, one, but not so deep in details. I mean, it makes sense when we do this upgrade. It's part of migration, maybe going to the cloud or Kubernetes. Have you tried in reality, like to do both, the .NET upgrade plus migrating to cloud?
Okay. So the question is, have we tried doing this upgrade, like tech stack upgrade, while also doing like a cloud migration upgrade? And the answer is yes. And the easiest way to do it, obviously, is if everything is in one place. So in the case that I'm thinking of, we migrated the legacy application to the cloud and the modern application to the cloud all at the same time, as well as doing YARP in front of them and so on. So it is possible to do. You don't even have to have the legacy application in the cloud, technically, but it does make things easier to have it there. So great question. All right, I think that's all the time I've got to take questions in this format, but feel free to come up afterwards. Thanks so much for coming today.